Hey Algebra 2, here are the notes for 13.3, day 2. So just a quick overview of the reference angle. Remember that the reference angle is always the terminal side connected to the nearest x-axis. That's going to come in handy when we start working on radian man. So let's start by investigating angles on the unit circle. And I've already got a lot of this written out, so bear with me. Essentially, what I did here was I just drew a general triangle in the unit circle. And I know that any general triangle is going to have a point on the circle, x comma y. And I know that any point on the circle, x comma y, is going to have a radius of 1 because it's the unit circle. And in order to get to that point, I have to go out x and up y. And that gives me a reference angle to work with. So if I talk about sine of a reference angle, I would say that it is y over 1, or just y. Now I could do the same thing with cosine of this angle. I could say cosine is x, my distance of x, over my hypotenuse over 1 is just x. So another way of writing x comma y is writing cosine of my theta comma sine theta. And this is going to be really big, so put some stars next to it to remind yourself. And then, while we can't necessarily see tangent right away, we know it's y over x. But another way to write y over x is sine of theta over cosine theta. This is another really big thing, so put some stars next to it. These are two things that I need you to remember. So now let's use that, specifically on the unit circle where we know that the reference angles in the first quadrant are 30, 45, 60, and of course 0 and 90. So if I want to find the reference angle, I want to find sine and cosine of 30 degrees, or of pi over 6, I know that a 30-degree triangle goes goes 1 root 3, 2. But because this has a radius of 1 and it goes over x and up y, another way to write that is shown right here. So sine of theta, sine of my reference angle, would be y over 1, or when I do this, it'd be 1 over 2. Cosine would then be root 3 over 2, and then because I know that, I can find tangent as well. So I'm going to jump over to radian man in my second video, but I want to finish these notes. Make sure you watch the radian man as well when we figure out how to find the rest of our values. So let's talk about what happens when our terminal side ends up on an axis. So because we know that x comma y is equal to cosine comma sine, we know that if something has a radius of 1, that's the same thing as having an x of 1 and a y of 0. Therefore, I know my xy is the same thing as my cosine sine, so cosine of 0 degrees, for example, is just 1. This ray, when it falls on an axis like this, is called a quadrant angle. So anything that is on one of these axes is going to be considered a quadrant angle. Now, we've organized all of this information into this nice little chart for you. However, this chart ultimately can just be made using radian man as well. So if you want to take the time to memorize the chart, you can, but really I just suggest using radian man. Again, check out that video, make sure you know how to make him. All right, last one. Suppose theta is an angle in standard position whose terminal side is in quadrant 3. So what I did was I immediately put my terminal side in quadrant 3. And then it says secant of theta is equal to -4/3. Well, I know that secant is the reciprocal of cosine. So what I did was I found that reciprocal. And then I know if cosine of theta is -3/4, I knew my adjacent side had to be 3 and my hypotenuse had to be 4. And because I went in the negative x direction, I knew that the negative had to go with the 3. Then, of course, I just used Pythagorean theorem to find my third side of -√7. And then when it told me to find the exact values of the remaining 5 trig functions, all I had to do was say, all right, here's my reference angle, because I connected it to that x-axis. And now to find sine, all I have to do is say opposite over hypotenuse is -√7/4. I then find the reciprocal, of course, to be cosecant of theta, -4√7/7. All I did there was I took the reciprocal of this, and then I had to rationalize the denominator. And I did skip that step. If that's a step you need some help with, let me know, come on in. Then I went to cosine theta, and I said, well, I already know that one. And if I already know cosine of theta, I also know secant of theta, also because the problem gave it to me. And then last but not least, find tangent by saying what is opposite -√7/3. So that's why I did not add that number. Oops. And if I know tangent, I then know cotangent to be 3/√7, but I have to rationalize to 3√7/7. So there are the notes for 13.3 day 2. If you have any questions, please don't hesitate to let me know.